Hi, in this video, we'll see a demonstration of how to use exception handling in Java. First, we'll start with simple example of using try, catch, and throw keywords using the built-in exception classes. And then we'll move on creating custom exception class. Let's get started. So we have a class called demo exception. I'm planning to add a main method. Inside my main method, I'm going to do division of 10 by 0 and I want to store that value in the variable called result. So result is equals to 10 by 0 divided by 0. Now I'm going to add system out.println and I'm going to print this result. So if I do this, program will be crashing. Now let's see what is happening. So it has crashed because of the exception in the train main java.lang arithmetic expression, and it is because by 0 at the main method. So we are trying to divide the number by 0. This is causing us an arithmetic exception. So how to handle this would be like you will need to use try block and monitor the risky code. So this code is going to now be monitored by the try block. And we'll also need a catch block, which is going to handle the exception. So use catch keyword, and the exception that we are getting is arithmetic exceptions. Put that inside this. We can put the sentence as error division by 0 is not allowed. Our own custom message that we want to put in the system out.println. So now let's try to run. So you see the difference now. We have handled the exception that is occurring from the code when you're trying to divide your number by 0, which is causing your arithmetic exception, by adding that code in your try block and handling the exception when it is going to happen with your catch block. So if we don't do this, we saw that we are getting a flow that is crashing your program and halts your execution, throwing the error just like that. So this is how you use your try catch block. Now let's say if you want to raise an exception yourself, how you will be able to do that. Now let's say that I have a variable called age, and let's say age is going to be 15, and I have a condition called age less than 15. So whenever the age is going to be less than 18, I wanted to throw some exception saying like it is some illegal argument exception, and I want a message to be printed saying that the age must be 18 or older. So to do that, I can use throw keyword and new and mention your exception name. This is an inbuilt exception, which is illegal argument exception. Inside that, put the message that you wanted to pass, which is age must be 18 or older. Let's try to run this. So if you see this, your exception is being thrown, and that exception is illegal argument exception because we ourselves have called this thing here. We are getting this message here. And the same thing could also be handled using your try block. Let's say try and use your catch block. To always catch an exception, you will have to use a catch block. So inside this, you can put, let's say I'm going to raise this error here. In the try block, I'm going to cause this exception, and age is above. Let's try to run. So we ourselves have introduced the exception, and we are trying to handle our own exception which we have raised using our catch block. So your try block will try to monitor your risky code, and your catch block will handle the exception whenever it occurs. So what I'm going to do is I'm going to create a method now, and let's try to throw an exception when this method is going to be called. So let's try to do that, and the method name is going to be, let's say, public void risky method. And whenever this method is going to be called, I want to throw my own exception. So this method should be throwing like IO exception and pass the message that I want to pass here, file not found. When this method is going to be called, I wanted to raise an exception. So whenever your method needs to throw an exception, you will have to use the keyword throws and declare it in your method signature. So you will have to use the throws keyword and mention the exception name, which is IO exception. Now let's try to call this method. So call that method, create an object. So demo exception class, variable is demo exception, and create an object. Now with the variable, object variable, try to call the risky method. Now when you're trying to call this risky method here, your main method should also be using the throws keyword, else you'll be getting a compiler error. So let's try to add the exception to the method signature. So you'll have to use throws IO exception, and now try to run this. So if you see, your method is calling your throw new IO exception error. So if we wanted to handle this, basically this method needs to come inside my try block. Let's put another try block and call this method there, so that if any exception is there, the try block will monitor that and your catch block will handle it. So your risky method going to call IO exception. So just call the IO exception parameter, and in the system out dot println error and plus e dot get message. Now when you try to run this, so you're able to handle your method throwing an exception inside your try block with catch statement. So the very reason why you use this throws IO exception in your method signature is you are trying to inform anybody who's going to use your risky method, like be prepared, this method is going to throw an exception. So when I mentioned that main method is like throws IO exception is because I'm calling a method which is going to throw me an exception. So I will have to mention it in the method signature. So we saw how to use try keyword, catch keyword, and we also saw throw and throws keyword. Let's check an example of how a custom exception can be created. So for creating a custom exception, I'm going to create a class called invalid input exception. So this is not a built-in exception. We are just creating this session itself now only. So you need to extend your class using your exception class and call the constructor. So public invalid exception string message. So your constructor for the class that is going to take a parameter which is going to be string and pass that to super message. So here what we are doing is your exception class has a constructor that accepts string argument to store the error message. So while calling the super keyword and passing your string inside this in your custom exception constructor, we are passing the error message to the parent class, which is your exception class. Also, your exception class has a couple of features with it, such as get message method, a print stack trace method, and there are also a couple of other exception handling utilities. To make use of these features, you will have to initialize the exception class properly with super keyword. Using this because you don't want to duplicate the logic of managing the error messages or any other exception related data. So with that note, let's try to go with a demonstration. Now say that I have a method called validate number. The method is going to take some number as input, and if that number is going to be less than 0, then I'm going to throw my invalid input exception, which is my exception which I have created, my custom exception. So let's try to create a method. I'm going to create a static method now, which has to accept integer type number. Now, if this number is going to be less than 0, I want to throw our throw keyword, new keyword, and invalid input exception. And in this, I want to pass some message. Number must not be negative. Like I said, whenever your method is going to throw some exception, you will have to inform it in the signature using throws invalid input exception. This method should not be inside your main method. Let's put that method outside and let's say throws invalid input exception here. Yeah. So we did that. Now let's try to call our static method, which is valid number. I'm going to call the valid number here and let's pass some negative value. So when you try to pass your negative value, add the method to your signature, and what we have to do is, like I said, handle it with try block, catch, and call your invalid exception, and system out dot println try to print the message, which is get message. When you try to run this, you're getting the message number must not be negative because you're passing a negative number. So one of the thing here is when you're trying to add your throws keyword in your method signature and then you're calling those method again inside your main method, you will have to add those throws in the main method as well, because in case if your risky method is not going to catch that exception, then your main method will be catching it, as your exception will be propagating to the main method as well. So it is required to mention the throws keyword in your main method also. This is called as exception propagation. Now finally, let's see how we can use multiple catch block. For example, inside my try statement, I'm going to have an array of numbers. It's going to be 1, 2, and 3. The system out dot println, I'm going to print the array of fourth element. And second, I'm going to have a result variable, and my result variable is going to be 20 divided by 0. So this is my try. And I have a catch block. In the catch block, I'm going to have array index out of bound exception E, and then system out dot println to handle it, error array index out of bounds. And I'm having second catch for the same try block, which is arithmetic exception system out dot println error division by 0. And This closes this one, and this bracket gets closed here, and this bracket gets closed here. Let's try to run. So you see that your array index out of bound exception is caught, and your second exception, which is result variable where the error division by 0 is not caught. So if multiple exceptions are occurring in your try block, the first exception thrown during the execution is caught, which is your this one. The remaining exceptions are not executed because the program will jump only to the first catch block which you have here. Here, another point that needs to be noted down is your catch blocks should be ordered from the most specific to the most general exceptions. For example, so I have array index out of bound exception, and then I have array exception. These are all like specific exceptions that are not most general. Like when I say most general, adding something like another catch, and when I put exception, print the exception. So now let's try to run this. So we see that this message has got printed and then followed by arithmetic exception and then your general exception method. So this order is very important because when you add this block here, I'm going to change this order in this way. We know that the first catch exception is going to be thrown. So these things are going to be overridden and it would be meaningless to have them after you put the most generic exception, meaning this is going to be an umbrella of all these exceptions. So it is better not to put this at the first in the order and put that at the end. Let's say that we also wanted to have some cleanup actions before we are going to close the exceptional handling. To handle such cases, we'll have to use the finally block. And inside the finally block, you can add the message that you wanted to be seen irrespective of your exception is happening or not happening. So let's say that this block gets executed no matter exception happens or not. Exception happens. Let's see that here. So you have your first array index out of bound exception has been printing, and let's also add something like e dot get message. So you have your error array index out of bounds, and your error is because your index that you're mentioning is 4, so that is printed, and what you have in your finally block is printed. The other exceptions are ignored because your first most matching exception is going to be executed and others are going to be ignored. Even if they have an exception that is going to happen, it's going to be ignored because your first one is almost taken by the first catch block. So maybe once this is going to be fixed, then your second could be handled. So from there, we'll also need to know that there is checked exception and there is unchecked exception. So when there is checked exception, you will have to throw your throws keyword in the method signature. Whereas if you will going to have some unchecked exception, then you don't have to add this throws keyword. So that is something that needs to be important, which is the basic difference between your checked exception and unchecked exception. Let's say, what do I mean by that? So the very beginning, we saw that we were handling arithmetic exception. So when we were checking this arithmetic exception where I was trying to run the result variable, which was trying to divide 10 by 0, I was not adding any throws keyword in my main method. That is because it's something that will happen only in the, you can find this thing in the runtime. So for that, even if you don't add your throws keyword, it is okay. Similarly, even for your null pointer exception. So your null pointer exception, your arithmetic exception, these are all derived from your runtime exception parent. So you don't have to add this throws keyword. Whereas for your checked exceptions, you will have to add the throws keyword.